All right, let's dive in. Today we're tackling a concept that's pretty much essential for anyone shooting for a senior software engineer role, especially when it comes to those system design interviews. We're talking about the abstract factory pattern.
It's definitely one of those foundational tools you want to have in your design thinking toolbox. Being able to show you can build systems that aren't just functional, but also really adaptable down the line.
Right, because adaptability is key. So let's start by imagining you're building an app, with a user interface. And, there's a good chance it'll need to support different visual styles later on. Maybe you start with a modern minimalist look, but then later you need to switch to something more traditional.
Exactly. And you can kind of think back to those older user interface standards like Motif or Presentation Manager.
Oh, yeah, those had very distinct looks.
They did. Each one defined its own specific appearance and behavior for all those basic elements like scroll bars, windows, buttons, the whole UI.
And if you were to, say, hard code the creation of those motif-style buttons throughout your entire allocation,
Oh, man.
what happens when you need to switch to Presentation Manager?
It'd be a nightmare, a massive refactoring project, probably riddled with errors.
Huge headache. And that's what we're talking about when we say tight coupling. Different parts of your code become so dependent on specific implementations that any change you make in one area could unexpectedly break something else.
Exactly. And the abstract factory pattern offers a pretty elegant way to avoid that whole mess.
Okay, so how does it do that?
Well, it basically provides an interface for creating those related UI widgets without actually specifying their concrete classes. It's like saying, hey, I need a button, but you let a factory decide whether you get a motif button or a presentation manager button based on, how things are configured.
So you're decoupling what you need, the UI element, from how it's specifically implemented.
Exactly. And
Yeah.
that's the key to flexibility.
Okay, I see where we're going with this. So the goal of this deep dive is to really understand this abstract factory pattern inside and out.
Yeah. We want to know when it's the right tool to use, how it's structured internally, and ultimately how it helps us build more flexible and maintainable systems. And those are definitely qualities you want to be able to talk about in a senior level interview.
For sure. So it's not just about name dropping the pattern, it's about understanding when and how to apply it to solve real problems.
Absolutely.
Okay, so let's start with the basics. What exactly is the abstract factory pattern trying to achieve?
All right, so at its core, the abstract factory provides an abstract interface for creating families of related objects without specifying their concrete classes. And sometimes you might hear it called a kit, which I think kind of gives you a good mental image.
Like a toolkit.
Yeah, like a set of coordinated components. And this whole idea of isolating the implementation means you can change things under the hood without breaking the code that's using those objects.
Which is huge for maintainability, right? Because it means changes are less likely to have those ripple effects that break everything.
Huge. So going back to our UI example, this kit would be the whole set of widgets you need for a specific visual style.
Gotcha. And it's all driven by the need to adapt and avoid those hard-coded dependencies that we talked about earlier. Because different look and feels mean different appearances and behaviors for the widgets.
Exactly. And to break free from that tight coupling, we introduce this concept of an abstract widget factory.
Okay, so what is this widget factory?
It's basically an interface, a contract, if you will. It defines how to create each basic type of widget. So you might have a create scroll bar method, a create window method, and so on.
So it's not actually creating those widgets, it's just defining how they can be created.
Exactly. And we also define abstract classes for each widget type itself. So an abstract scroll bar, an abstract window, and so on. Then for each specific look and feel we want to support.
We create a concrete subclass of the widget factory.
You got it. So for example, you'd have a motif widget factory and a presentation manager widget factory.
And those are the ones that actually do the work of creating the specific widgets for their respective style.
Right. So inside the motif widget factory, the create scroll bar method would actually create and return a motif scroll bar object. And in the presentation manager widget factory, the same method would return a presentation manager scroll bar. But the important thing is that the client code, the part of your app that needs a scroll bar.
It doesn't care which one it's getting.
Exactly. It just knows it needs a scroll bar. It interacts with the abstract widget factory interface and asks for a scroll bar without knowing or caring about the specific implementation.
Okay, that's pretty slick. The client just says, give me a scroll bar, and the currently configured factory takes care of the rest.
Yep. That's the beauty of decoupling. The client is only committed to the interface, not to any particular concrete implementation. So you can easily switch the entire look and feel of your app by simply using a different concrete factory.
And that makes maintaining the code so much easier. Because if, let's say, a new UI standard comes along, all you have to do is create a new concrete factory and the corresponding widgets, and your core application logic doesn't really need to change much at all.
Right, you just plug in the new factory and you're good to go.
That's awesome. And, there's another benefit here, which is consistency.
Oh yeah, that's a big one. The abstract factory helps ensure that all the widgets you use together belong to the same family. So if you're using a motif widget factory, you're guaranteed to get a motif scroll bar, a motif button, and so on. It prevents you from accidentally mixing widgets from different styles, which can lead to a really messy and unprofessional user interface.
Yeah, you definitely don't want a Frankenstein UI.
Exactly.
Yeah, thinking about those senior level interviews, let's say you're discussing a system design. What are the signs that the abstract factory pattern might be a good solution?
So the biggest red flag is when you see a system that needs to be independent of how its products are created, composed, and represented. If those concrete classes are likely to change or you think you'll need to swap them out easily, that's a good indicator.
So kind of like our UI example, where we might need to support different visual themes.
Exactly. Another scenario is if your system needs to be configurable with different families of products.
So you could have like a DirectX rendering factory and an OpenGL rendering factory, each producing a set of rendering objects specific to that API.
That's a perfect example. And then there's the case where you have a bunch of related objects that need to work together, and you really need to enforce that constraint.
Because otherwise you might end up with incompatible objects trying to interact with each other, which would cause problems.
Yeah, that's where the abstract factory comes in to make sure everything plays nicely together. And finally, if you're building a class library and you want to expose only the interfaces of your products, not their specific implementations, the abstract factory can help you achieve that.
Makes sense. You're essentially giving the user a contract without revealing all the details of how things work under the hood.
Precisely.
Okay, so we've talked about what the abstract factory is and when it might be useful. Let's break down the actual structure of the pattern, the different parts and how they fit together.
All right, so we've got 5 main players here. First up is the abstract factory itself, which in our UI example was the widget factory. This guy defines the interface for creating those abstract product objects like create scroll bar and create window. It's basically the blueprint for what kinds of objects can be created.
So this is kind of like the high-level plan.
Right. Then we have the concrete factory, which are the specific implementations of the abstract factory. So we'd have our motif widget factory and our presentation manager widget factory. Each concrete factory knows how to create the concrete product objects for its specific family.
So these are the actual builders.
Exactly. Next up is the abstract product, which defines the interface for a type of product object. So this would be our abstract window class and our abstract scroll bar class.
Okay, so this is like the contract for what each product should be able to do.
Right. And then we have the concrete product, which are the actual implementations of those abstract product interfaces. So the motif window and motif scroll bar would be concrete product examples created by the motif widget factory.
So these are the actual tangible widgets that the user sees and interacts with.
Yep. And finally, we have the client, which is the part of the code that uses these products. And the key here is that the client only interacts with the interfaces defined by the abstract factory and the abstract product. It doesn't know anything about the concrete factories or the concrete products they create.
So the client just asks the abstract factory for a scroll bar and then works with that abstract scroll bar without ever knowing if it's a motif scroll bar or a presentation manager scroll bar.
Exactly. That separation is what gives us the flexibility and independence we want.
Okay, so we've got our cast of characters. How do they actually interact in a running system?
So typically what happens is that you create a single instance of a concrete factory at runtime. And that factory is then responsible for creating all the product objects of that particular implementation family.
So if you're going for the motif look, you create one motif widget factory, and every time you need a widget, you ask that factory for it.
Exactly. And if you later decide to switch to presentation manager, you just use a different concrete factory, and the rest of your code doesn't need to change much at all.
Which is a huge win for maintainability.
Yeah.
Right?
Yeah.
Because it means you're not constantly having to rewrite code
Yeah.
when you need to make changes.
Massive win. And it's also important to remember that the abstract factory itself doesn't actually create the objects. It delegates that responsibility to its concrete factory subclasses.
So the abstract factory is like the architect, and the concrete factories are the builders.
That's a good analogy.
Okay, so we've covered the structure and the interactions. What about the consequences of using this pattern? What are the advantages and disadvantages?
Well, we've already touched on some of the benefits, like isolating the concrete classes and making it easy to swap out entire product families.
And ensuring consistency among the products.
Right, and those are all major advantages. But there's also a significant downside, which is that adding new product types can be difficult.
Right, because the abstract factory usually has a fixed set of products it can create.
Yeah. So if you need to add a new type of widget, you might have to change the abstract factory interface, which means changing all the concrete factories as well.
And that could be a lot of work.
It can be. So that's a trade-off you need to consider.
Makes sense. Okay, so how do we actually go about implementing an abstract factory? What are some common techniques?
Well, one common approach is to implement those concrete factories as singletons.
Because you usually only need one instance of each concrete factory, right?
Exactly. There's no need to have multiple motif widget factories floating around. And then for actually creating the products, the most common way is to use factory methods.
So each concrete factory would have a specific factory method for each type of product it creates.
Right. But sometimes that can lead to a lot of concrete factory subclasses, especially if you have lots of product families that are only slightly different. So in those cases, you might consider using the prototype pattern.
Remind me how that works again.
So instead of creating a new concrete factory for each minor variation, you have one concrete factory that's initialized with prototype objects for each product. And when you need a new object, the factory just clones the appropriate prototype.
Oh, right. So you're essentially defining new product families by just changing the set of prototypes in that one concrete factory.
Exactly. And it can be a lot more efficient than creating a whole new subclass for each variation.
That's pretty clever.
And there's another variation that's often used in more dynamic languages, which is a class-based approach. Instead of prototypes, the concrete factory stores the classes of the products it can create.
So you're basically saying create a new object of this specific class rather than cloning a prototype.
Exactly. And that gives you even more flexibility because you can configure a factory at runtime just by giving it the classes you want it to use.
Very cool. Now, we talked about how adding new product types can be tricky. Are there any ways to make those factories more extensible?
Well, the traditional approach of having a specific method for each product type in the abstract factory makes it difficult to add new types. A more flexible way is to have a single generic make method that takes a parameter specifying the type of product to create.
So instead of create scroll bar and create window, you'd have one method called make, and you'd pass in something like scroll bar or window to tell it what to create.
Exactly. And that makes it easier to add new types without having to change the abstract factory interface itself. But there's a trade-off there, especially in languages with static typing.
Because the return type of that make method would have to be pretty generic, right?
Yeah. So if you need to do something specific with the object you get back, you might have to do a downcast, which can be risky if you're not careful.
So you gain flexibility, but potentially lose some type safety.
Exactly.
Okay, so we've covered a lot of ground here. To make this more concrete, let's talk about a classic example, the maze example.
Oh, yeah, this is a good one.
So we're building a system to generate mazes. We've got rooms, walls, doors, the whole 9 yards. How does the abstract factory fit in?
So imagine your first approach is to just create those room, wall, and door objects directly in your maze creation code. But what happens if you want to create different kinds of mazes later on? Like, what if you want an enchanted maze with magic rooms and doors that require spells to open?
Or a maze with bombs hidden in some rooms?
Exactly. That's where the abstract factory comes in. You create a maze factory that defines the interface for creating those maze components. And then you change your maze creation function to take a maze factory object as a parameter.
So instead of calling new room,
Yeah.
you'd call something like factory.makeroom.
Precisely.
Right.
And then you can create different concrete maze factory implementations. So you could have a basic maze factory that creates standard rooms, walls, and doors. But then you could also have an enchanted maze factory that creates enchanted rooms and doors that need spells.
And a bomb maze factory that creates rooms with bombs and walls that can be blown up.
Exactly. And the beauty is that your main maze creation function doesn't need to change at all. You just give it a different factory and it creates a different kind of maze.
That's really powerful. You can create all these different variations just by changing the factory.
Yep. And in simple examples, the maze factory itself might actually be a concrete class with those factory methods. So it acts as both the abstract factory and a default concrete factory.
Now, you don't necessarily have to start with a separate abstract factory interface right away. You can add that later if you need it.
Exactly. And if you're using a language that supports it, you could even have a maze factory with a single make method that uses a catalog of component classes.
So you'd basically configure that catalog with the specific classes you want to use for each type of maze component.
Right. And that gives you a lot of flexibility to define new maze variations without creating a bunch of new subclasses.
Very cool. So we've talked about the maze example. Are there any real-world systems that use the abstract factory pattern?
Oh, yeah, tons. One famous example is Interviews, which is a user interface toolkit. They actually use the term kit in their abstract factory classes. So they have things like widget kit, dialogue kit, layout kit. These kits are abstract factories for creating UI objects and layout managers.
Makes sense. And when they need to create UI elements with a specific look and feel, they just use the appropriate kit.
Exactly. Another good example is ET++, which is an application framework. They use the abstract factory to achieve portability across different windowing systems.
So you can run the same application on X Windows or SunView without having to rewrite a lot of code.
Right. They have an abstract window system class that defines how to create windows, fonts, colors, all that stuff. And then concrete subclasses implement those methods for each specific windowing system.
So the application code just interacts with the abstract window system, and the concrete factory handles the platform-specific details.
Exactly.
Okay, last question. How does the abstract factory relate to other creational design patterns?
So it's often implemented using factory methods, which are those specific methods for creating objects that we talked about earlier. And it can also be implemented using the prototype pattern, where you have a factory that manages a collection of prototype objects. And those concrete factories are often implemented as singletons to ensure that there's only one instance of each one.
So they all kind of work together to solve different aspects of the object creation problem. All right, so just to summarize, the abstract factory is a powerful pattern for creating families of related objects. It helps you isolate concrete classes, make it easy to swap out entire product families, and ensure consistency. But the main downside is that it can be tricky to add new product types.
Yeah, that's a good summary. It's a trade-off you need to be aware of.
So for all of you out there preparing for those senior level interviews, think about a complex system you've worked on. Where could you have used the abstract factory pattern to make the design more elegant or more flexible, and what would have been the trade-offs? If you can walk through that kind of thought process, you'll be in great shape.
Definitely. And definitely take some time to look into those related patterns we mentioned: factory method, prototype, and singleton. The more you understand those patterns, the better you'll be at designing and building software.
Couldn't agree more. Understanding design patterns is key to becoming a successful senior software engineer. Thanks for joining us, and we'll see you on the next deep dive.